Hello, today's lesson is about algebraic expressions. And what I said on the left was we can represent real-life situations using mathematical terms and operations. You're very familiar with operations and you're very familiar with mathematical terms. You just might not be used to calling it mathematical terms. But it is important that we understand the parts of these representations. And so in this chapter, you will be learning about variables, algebraic, and numeric expressions, and you might already realize that numeric sounds like number, so it's an expression that has numbers. And algebraic sounds like algebra, which is when we start using letters to represent numbers. And then, of course, you're familiar with equations and terms, coefficients, and constants. So these three are probably going to be new vocabulary words for you, even though you've probably seen them represented, you just haven't actually thought about giving them a name. So you can see that I have an example of an algebraic expression. It has an operation, which is a plus sign. It has another operation right here. When you see a number next to a variable, it means to multiply. So even though you don't see a symbol, there is an operation there. And so you see 5p plus 4. And so this is called an algebraic expression. It has numbers, it has variables, and it has operations. And then this is the tricky part that's underlined in blue. Terms are separated by addition and subtraction symbols. And in this box it says, well, this makes sense because remember we don't use, well, you don't know this yet, but in higher math, a lot of times you don't use division symbols like this, and you're not going to be using multiplication symbol and x for a multiplication symbol because x looks like the variable x. So we stop using division symbols and then x to mean times when we get into higher math. And then I want you to see that when you have a number by itself, right, this is just plus 4, it's called a constant. If you look up the word constant in the dictionary, it means true or steady, something like that. But the idea is, hey, if you have a constant, it never changes, right? 4 will always be 4. And then there is a different number that's called a coefficient. This is a number that tells you how many groups of p you're going to make, right? So if this is the variable p is an unknown number. And the 5 in front of it is kind of like you've seen a multiplier before, right? So you can think of this as 5 groups of p. We just don't know the number that p represents, but it's called a coefficient. And if you know your prefixes in English, co means with. So you can think about it as the number that's with a variable. A constant, con, means not. So you can think of the constant as the number without a variable. So a number with the variable is a coefficient, and a number without a variable is a constant. So that's just an introduction to the names that we give parts of expressions. Okay, so again, variables are letters mostly, but you can use anything to represent a variable. A box like this. You probably, let's see, maybe even back in 2nd grade, they would say 3 plus what number equals 5? So you're probably all thinking, well, of course it's 2, right? 2 goes in the box. So this box can represent an unknown number. Or a lot of times you would see this, 3 plus what number equals 5? And so not only do you use letters to represent unknown numbers, you can use a box, you can use a question mark. And some of the way we think about a variable is it can vary or change. But like in this instance, the only number that makes this box true is a 2. But then I could write another expression. And what if I say 10 minus this box equals 9? Well, in this example, you know that 1 goes in the box. So this box represents the number 1. In this equation, this box represented the number 2. So we call it a variable because it can change. Now, in one equation, that variable cannot change. It has to be the same number. But notice in 2 different equations, this box stands for different numbers. And some of the ways we can think about it is, hey, guess what? The number of students present in class each day could vary. So I could use the variable S for the number of students. How about the number of cars in a parking lot, right? I would probably use the letter C to represent the number of cars in a parking lot. And then when you talk about the number of seconds or minutes that have passed, I usually use the variable T to represent time. Okay. So when you start changing algebraic expressions and you rewrite them, I just want you to see that I'm not asking you to do any math first. If I ask you to write an algebraic expression, that means there's either numbers or letters and there's operations. You already know that these dots means times, right? And so you can't come up with a value, a number for what is d times d times d times d unless I tell you what d is. But now all I'm asking you to do is, hey, can you write this expression using exponents? And you remember that exponents tell you how many times to multiply a base. And the base is d, right? So I'm just going to remind you that the base is d. And the exponent is how many times it's multiplied. So the exponent in this case would be 4. So the way I write this is d to the 4th, and that's it. I'm basically creating an equivalent expression, but it's easier to write d to the 4th than it is to write d times d times d times d. Okay, so let's look at another example. This time I do have a number in front of it. And I know if I look at the exponential part of it, I'm going to have the base is going to be h, and my exponent is going to be 3. And so I know I have h to the 3rd power. And then if you remember that all of these are multiplied together. So what I need to do is this becomes my multiplier. So it's sort of like 1.5 groups of h times h times h. Well, that's the same thing as h to the 3rd. So if I'm still multiplying, I just put the number next to the variable. Now notice that this exponent 3, it is not next to the 1.5. So this doesn't mean 1.5 to the 3rd power. The exponent only has power over the letter that it is right next to. And if you could, I won't say that this is wrong, but this is not the best way to write it. You could write 1.5 in parentheses because parentheses next to a variable also means multiply. But this is the preferred way to rewrite that expression using exponents. Notice I don't have a final answer because I'm not telling you what h equals. I'm just getting you to write expressions sort of using shorthand. All right, now we're on to the OYO. So this is OYO, and I want you to pause the video and I want you to try. Remember, I'm just asking you to rewrite the expression using exponents. Go ahead and pause it, and then I'll go ahead and continue. Notice that there's 1, 2, 3, 4, 5, 6 j's. So my base is j, and the exponent is 6. You don't have to write this every time. I'm just writing it so that you know where I'm getting these variables and numbers from. So this is the same thing as j to the 6th. It is so much easier to write j to the 6th than to write out all those j's. Okay, in this example, I tend to look at the variable first. 1, 2, 3, 4, 5 k's. So my base is the variable k, which stands for a number, and my exponent is 5. So I know I have k to the 5th, and then it's being multiplied times 9. So I just put a 9 in front of it. There's no need for parentheses. That's what that expression looks like. Okay, so a lot of times you see math problems that ask you to evaluate, and the root of this word is value. And so the idea is you are finding the value of an expression, and this is what Mrs. Clifner calls do the math. So whenever I ask you to find the value, I am asking you to do the math. To evaluate is to tell me the value or do the math. And so we'll go over these examples. So notice here's my expression, k plus 10. But now I'm telling you, hey, guess what? I want you to let k equals 25. So now I know 25 is the value that I substitute in for k, and then I just do the math. 25 plus 10 is 35. Okay, here's another example. Evaluate 4 times n when n equals 12. So I'm going to rewrite this as 4 times 12, and I know that 4 times 12 is 48. So this is simply asking you to do the math, but I'm going to give you the value for the variable. And this is getting you ready to do some more complicated formulas later on in your math career. Next, this is the OYO. So go ahead and pause the video and you're going to try these two OYOs. So 6 is instead of the C, I'm going to replace the C with a 9. And I know that 24 plus 9 is 33. And for 7, I'm going to replace the D with 30. And if I'm not good with mental math, then I'm going to go ahead and set up my subtraction, and I'm going to regroup, and I get 13. Okay. Next, I have a red star here because I want you to write this down. This is not like you will see every teacher will tell you this is what you need to do to evaluate expressions. This is just my suggestion for an easy way to not make silly mistakes when you're working with expressions, and particularly if there's more than one variable. So please write down these 4 steps for evaluating expressions. The first thing is you write down the expression. And then I'm asking you to put parentheses, right? Parentheses, you put those around each of the variables. And then you're going to substitute or plug in the value given for each variable in the parentheses. And then the last thing is evaluate. Guess what? Do the math, but you must use the correct order of operations. So go ahead and pause the video while you're writing that down. And then, of course, we're going to go to a couple of examples and some OYO. Okay, so now here is an expression that has 2 variables. And so if you look at the steps that I gave you, I asked you to write A, right, divided by B. And notice that I'm putting the A and the B in parentheses. And then a lot of times what I do is I get a highlighter. And I highlight the A, right, is worth 16. So I'm going to highlight the A. And then the B, I'll do in green. B is 2/3. And I color code it so that when I plug in my numbers, I don't make any mistakes. So right now, I've got A divided by B. And so I'm going to write right underneath it. A is my 16 divided by B is 2/3. Now, I didn't write you know how I said in higher math, you don't see the division symbol. Well, of course you do in this one, but A, you know that A with the division symbol looks like this. But I thought that this might be a little tricky if you saw this. But basically, if I'm writing 16 divided by 2/3, it's a compound fraction. So it's a fraction in a fraction. You've never probably seen that before, and it looks a little scary. So I'm showing it to you like this so that you can see, oh, hey, we just learned how to divide fractions. I know how to do this. When you want to divide, look on the right side, flip that fraction over, and then you multiply. I wasn't sure if you would get that idea looking at a compound fraction. So now I'm going to put the 16 over 1 because I want to turn it into fractions. And I'm going to flip the 2/3. So now I have 3/2. And now I'm going to simplify before I multiply. 2 goes into 2 once, 2 goes into 16 8 times. What I'm left with is 8 times 3 over 1 times 1, which equals 24. 24 divided by 1 is just 24. Okay, so again, you don't have to put the variable in parentheses, but I feel like if you do, it's much easier to not make mistakes and accidentally put the 2/3 in place of the A, put the 2/3 over where the A is supposed to be, where the 16 is. Okay, so now you've got 4 examples that I want you to try on your own. I recommend color coding. So I'm going to do the P in red, and I'll do the Q in green. So I'm going to go through and I'm going to highlight. Notice on this example, the Q was first. So I'm going to highlight in green where the Q is, and then I'm going to highlight in red where the P is so that I make sure that I get the right number in the right place. Okay, and now I'm going to do number 8. And so Mrs. Cliffner says use parentheses and then substitute in the number. So P is 24, and this is Q is 8. Oh, 24 divided by 8 is 3. That one was easy. Okay, let's look at number 9. Q goes first, and Q is the green one, so I need to write 8 first. 8 plus 24, and then I know I can do mental math on that one and get 32. Okay, number 10. P minus Q. Super important that you write subtraction in the right order, right? It's not commutative. If you change the order of subtraction, you change the value. All right, well, maybe I'm not as good at mental math on this one. Maybe I could write it out and show the regrouping. I get 1. All right, 16. And number 11, remember that a variable next to a variable means to multiply. So I'm writing 24. I'm writing times 8. And then, okay, now I have to do my long multiplication. 32, regroup the 3, 16, 19. I get 192. Okay, I hope those OYOs were fairly easy. And now I'm going to show you some other examples where we have, instead of 2 variables, now we have 2 operations. But it's the same idea, but now you are going to have to pay attention to order of operations. And so I am going to highlight, there's only one variable, but it doesn't hurt to highlight the variable. And so I'm going to go ahead and highlight the variable here, and the z equals 2. Okay, so now I'm just going to rewrite the expression first, and I am going to put a parentheses in place of the variable because I want to make sure that I'm basically plugging that 5 into where the x is. So I'm going to write 3 instead of the x. Now I've got 5 minus 14. Remember, order of operations says you have to do multiplication first. So I get 15 minus 14, all right, is 1. And for this example, it's z squared, but I'm going to write the z here in parentheses squared plus 8.5. And then in place of the z, I'm putting in a 2. So now I've got 2 in parentheses. But all that means is whatever is in the parentheses gets multiplied by itself 2 times. So I get 2 times 2 plus 8.5. 2 times 2 is 4. So now I have 4 plus 8.5. If I can't do mental math, I'm going to go ahead and add and line up the decimals. Super important that we're adding the right place values. And I get 12.5. Okay, so when you have more than one operation, remember you have parentheses, exponents, multiplication and division, addition and subtraction. And remember, you go left to right when you're choosing between multiplication and division, or if you're choosing between addition and subtraction. But addition and subtraction are always the last operation. Okay, so now we've got some OYO, so go ahead and pause the video. You're going to write all these down, and I'm going to highlight the y equals 6, and I'm going to highlight the y. This is where I'm putting in 6 for all of these examples. Pause the video and see how you do, and then unpause and check it. All right, number 12. I'm going to rewrite it using parentheses because it makes my life easy, and then I plug in the 6 for y. So I have 5 times 6 plus 1. I have to do multiplication first, so 30 plus 1, I get 31. And then for 13, I have 30 minus 24 divided by y. And even though it seems like a little bit of a pain to rewrite it this many times, I'm less likely to make mistakes as I plug in the variable. Okay, so I've got subtraction and division comes first, right before subtraction. So I need to do 24 divided by 6 is 4, and then I have 30 minus 4, and I get 26. And then I'm going to write the y in parentheses, y squared minus 7, and I know that I'm substituting in 6 for y, so I get 6 squared minus 7. 6 times 6 is 36 minus 7. If I'm not good at this mental math, I'm going to show you my regrouping. 16 minus 7 is 9. 2 minus 0 is 2. I got 29. And the last one is 1.5 plus y squared. And so it's 1.5 plus 6 squared. 1.5 plus 36. I get 37 and a half. Okay, and that is today's lesson.